So today we're going to continue with just more derivative ideas. And the first one we're going to start with is an alternate definition of the derivative. We looked yesterday at our formal definition of the derivative that said f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Today we're going to look at an alternate definition of the derivative, which is easier to use, but in some ways is a lot less useful. And what this definition is going to find for us is the derivative at a specific x value. It's not going to be like yesterday, where when we're done, we have a formula for the derivative that I could plug any x value in and find the slope anywhere. My work is just going to find the derivative at x equals 2. And if I want to find the derivative at x equals 3, I need to go back and start the process over. X equals 5, start it over. So in some ways, you'll see it's going to look a little bit nicer. In other ways, it's a little less useful. I want to find the derivative at x equals c. So the slope of a line tangent at x equals c. So first of all, I have the point c, comma f of c, right over there. I'm going to put some other points on this function and get myself a nice secant line through them. And I'm going to call that other point x, comma f of x. I've got x, comma f of x there, and c, comma f of c over there. I want to find the slope of that secant line, and then basically take this point, move it really, really close to x equals c, and get my slope of a tangent line, my derivative. F prime of c equals. Okay, well, what's the slope of this line going to be? It's going to be f of x minus f of c over x minus c. The slope of my secant line, f of x minus f of c over x minus c. How am I going to now say, move this random point x comma f of x really close to c comma f of c? Well, first of all, I need a limit, and I want my x value to get really close to c. This is my formula for the alternate definition of the derivative. Let me show you two examples on how to use this. Let's say f of x equals x squared minus 6x. And we're going to find f prime of 4 using the alternate definition. I'll say use the formal definition if I want you using limit as h approaches 0 of f of x plus h minus f of x over h. And I'll say use the alternate definition if I want you using this one. F of x equals x squared minus 6x. Find f prime of 4 using the alternate definition. Pause this if you're not ready to go on. But if you are ready to go on, my formula says that f prime of 4 equals the limit as x approaches 4 of f of x minus f of 4 over x minus 4. Okay, well, now I need to go find f of x and f of 4. Limit as x approaches 4. Well, f of x, that's really easy. F of x is just this formula. It's just x squared minus 6x. F of 4, you know what, how about I do a little bit of work on the side over here? F of 4 is going to equal, actually, you go do that. What's f of 4? 4 squared minus 6 times 4, that is 16 minus 24. You're going to get negative 8. So minus negative 8, I'll clean that up in a moment, over x minus 4. This is the limit as x approaches 4 of x squared minus 6x plus 8 over x minus 4. At this point, you should plug in 4, but if you do that, you're going to get 16 minus 24 is negative 8 plus 8 is 0, 0 over 0. Yeah, that's not going to work. So what do we have to do next? You're going to go factor and cancel. So go do that. Go factor, cancel, finish this off, and get that limit. this is going to be the limit as x approaches 4 of x minus 4 over x minus 2 over x minus 4. Really nice. Those x minus 4s are going to cancel. We're going to get the limit as x approaches 4 of x minus 2. 4 minus 2, you're getting 2. Which means f prime of 4 is going to be 2. The slope of this particular parabola at x equals 4 is 2. I feel like this work was so much easier than the work we did in the previous couple of videos with the formal definition. Here's the problem, though. If I want you to find f prime of 3, you can't use any of this work. You've got to start the problem over and say f prime of 3 equals the limit as x approaches 3 of f of x minus f of 3 over x minus 3, and really go through the work again. So you lose in one sense, you gain in another sense. It's just a different way of finding it. Not better or worse, just different. Okay, well, let's try another one. Let's say that f of x equals 1 over x. Let's find f prime of 3 using the alternate definition. F of x equals 1 over x. We're going to find f prime of 3 using the alternate definition. F prime of 3 is going to equal the limit as x approaches 3 of 1 over x minus 1 over 3 over x minus 3. And I'm realizing I probably should have started by saying f of x minus f of 3. Whatever, you got that. Well, then you need to go get a common denominator up top. And the common denominator is, hopefully you said 3x. I'm going to go do the limit as x approaches 3 of, okay, so I want to get that common denominator. I'm going to multiply by 3 over 3. I'm going to multiply by x over x. This is going to give me the limit as x approaches 3 of 3 minus x over 3x all over x minus 3, or over x minus 3 over 1. Rather than divide, I'll multiply by the reciprocal. Let's see, f prime of 3 equals the limit as x approaches 3 of 3 minus x over 3x times 1 over x minus 3. You know what? See if you can go finish this off. I'm going to go put this in standard form. Actually, that's negative x plus 3, so I can then go factor out a negative from that. I've got the limit as x approaches 3 of negative 1 times x minus 3 over 3x, x minus 3. Gone. I'm going to plug in negative 1 over 3 times 3. Please don't tell me negative 1/6. 3 times 3 is 9, and you're going to get negative 1/9 there. If your directions say alternate definition of the derivative, this is the work I'm looking for. If they say formal definition, that's where I need the limit as h approaches 0 and all of that good stuff. F of x plus h minus f of x over h, that stuff.